Thank you very much. Just want to clear up a misconception in some of the documentation. I'm described as TIBCO's Chief Technology Officer for the region. I can assure you I'm not TIBCO's Chief Technology Officer for the region. That's Paul, and Paul's a much better looking man than me. And he's not with us this week, so you get my good self. So we're going to talk today about something, if I can find the slide changer. We're going to talk about what TIBCO calls the event-enabled enterprise. And to put that in context, today I'm going to call it the event-enabled mining enterprise. Now, I know that there are a mixed bag of delegates here today. Some people are from the software side of mining technology, a lot of people aren't. And so I'm going to try and steer away from too much detail on the technical side and take you through a story about TIBCO, what TIBCO is and how we work in various industries around the world, and then we're going to focus down on how we apply some of our tools to the mining industry in a practical sense. So, the basic premise of TIBCO's go-to-market model is a statement that we call the 2-second advantage. And a little bit of background about TIBCO first. TIBCO is a typical Silicon Valley software company. It was started 20 years ago by that gentleman, Vivek. It wouldn't be a typical Silicon Valley software company if it didn't have a resident billionaire. That's our resident billionaire. TIBCO started on Wall Street. So TIBCO's first application was for one of the banks of Wall Street. I believe it was Goldman Sachs. And the innovation that they applied to Goldman Sachs then was to integrate the data feeds for the trading desk. And so TIBCO has its roots on Wall Street in processing information feeds for the finance industry, the trading industry, and we're still fairly well entrenched in that business. So if you know anything about high frequency trading systems that you see written up in newspapers nowadays, a lot of TIBCO technology is at the heart of that. In fact, I was at a conference in Las Vegas a couple of weeks ago, and we announced an appliance for the high-frequency trading industry that will process 4 million transactions a second, which in software, hardware terms for that industry is a lot of trading in a very short period of time. So our roots go back to processing large amounts of data. Since those days, 20 years ago, we've expanded. We're now $1 billion in revenue. We have a market capitalisation approaching $5 billion. We have 4,000 clients around the world, and they're fairly broadly spread across a range of different industries. So the 2-second advantage in TIBCO's terminology is based on this premise, that a little bit of the right information beforehand, whether it's a couple of seconds, minutes or hours, is more valuable than all the information in the world 6 months later. And if we ask ourselves how we deliver that 2-second advantage to an organisation, the best way to describe it is that we transform a typical IT operation into an event-enabled IT operation or an event-enabled enterprise. And so you'll see with the TIBCO marketing material this E3 logo, and that's really what we're getting at there, is to transform organisations into what we call event-enabled enterprises. And to do that, we have a platform of technology, and so TIBCO has a lot of tools. If you compare the breadth and depth of our tool set with our nearest competitors, and I think the people that we come up against most in the space that we work in is probably IBM and Oracle. If you compare the breadth and depth of our tool set, you'll find that it is probably more focused on this specific event enablement that we focus on than any of our other competitors. The 5 categories of our platform are automation, event processing, analytics, cloud, and social. And if I just touch on those a little bit, automation in the TIBCO world is all about integrating applications and providing visibility of the data flows amongst those applications. If we then move on to event processing is applying the intelligence to that information to be able to derive events. So understand what the information means in context and try and act on that information before something critical happens. So anticipate something that's going to happen and then let the system make decisions, or present the options to the operators so that they can make decisions based on that real-time information. We have an analytics suite, and if you come to our booth out here in the trade area, we have some fantastic real-time analytics tools that we can show you. And I think the main point to make there is we're not talking about business intelligence in a traditional data warehousing sense. We're talking about real-time analytics. And you'll see that thread through all the content in this presentation, is that most of the TIBCO technology is talking about real-time processing, real-time event management, real-time analytics. And with all this information comes a requirement to be able to burst processing capacity to meet demand. And so we have a raft of tools that support cloud deployment of our solutions, but also support dynamic allocation of IT resources to be able to keep up with abnormal spikes in information flows. And of course, the social side, TIBCO has a set of tools that help us disseminate the information out to the organisation. So it's one thing to build the solutions in IT, but getting that information to where it's needed is really the function of our social tool set. So let's try and make that happen. So how does this manifest itself in the real world? What do we actually do with this? I'll give you a few examples. Some industries that you would know are FedEx, for example. FedEx runs its entire transaction processing operation on TIBCO technology. We process 2 billion transactions a day for FedEx. So if you ever do a track and trace for a parcel somewhere in the world in FedEx, it's a transaction across a TIBCO integration platform. We do a lot of work in fraud detection in the banking industry. So credit card fraud, real-time detection of fraudulent transactions as they occur for the likes of Citibank. There are a raft of banks around the world. And we have a project we don't talk much about with a fairly famous online store where we're processing 1 million transactions a second to detect fraudulent transactions there as well. And so you get the theme that TIBCO is able to process large volumes of information, make sense of that information, analyse the information in split-second time, and then take action on the information across a raft of industries. This is an example that is probably a little closer to mining. It's more heavy industry. This was Union Pacific. Union Pacific has got some stats that I can't remember, so I'll have to read them. Union Pacific have 8,000 locomotives in the US. They have 300,000 rail cars, which is staggering numbers for a logistics organisation, and 25,000 customers. And if you look at the distribution of those assets across the United States, the data feeds coming from the track, from the trains, from external sources, customers, freight yards, suppliers, customs agents, the weather feeds, the crew schedules, all of the data sources that impact the performance of that operation are staggering and diverse and distributed across the country. And so our objective at Union Pacific was to increase the velocity of the trains, the average velocity of the trains across the track network. And by increasing the velocity of the trains from 17 miles an hour to 20 miles per hour, we saved Union Pacific $30 million a month. Now, to do that, we integrated all of those data sources, all of those information feeds, and then applied an intelligent analytic layer across the top of that to be able to better react to the events that occur across their network. So react better to crew no-shows, react better to weather events, react better to maintenance requirements, to be smarter about the way the assets were taken offline for maintenance, and when they were taken offline, be more efficient in what you maintain and how you maintained it. And so the Union Pacific story from a heavy industry perspective, I think, has got a lot of parallels in the mining industry, as the mining industry is trying to integrate its supply chain, demand chain, and drive better efficiencies out of their operations. Another example that I quite like is Southwest Airlines. Southwest Airlines, again, it's like rail, only the assets are in the air. but same impact. A lot of data feeds. In the US, in some areas, the weather events have a significant impact on the schedules of the flights. And so for Southwest Airlines, we took all of the data feeds from the airport, weather, maintenance, crews, schedules, and brought that together in a system that could help the operators optimise the way the fleet was run. And there's some interesting stories and solutions that came out of the maintenance side of that particular solution that I'll talk about a little bit later on to save repeating myself. But as we did with Union Pacific and we did with Southwest Airlines and Delta Airlines, the objective of the solution was to integrate a lot of disparate data sources in real time and try and squeeze small percentages of operational efficiency out of these organisations, which results in a significant cash saving for them. And in Southwest Airlines' case, they always talk about better customer service as well. So making sure the planes fly on time, making sure that people are aware of any delays and have a better experience when they're flying with Southwest. So the question is, and one of the speakers yesterday mentioned the IT-OT convergence in mining. And it's something that has become quite a topic of conversation in mining in the last 12 to 18 months. And in fact, last year I was on the sidelines of some integration of some of the traditional vendors, the Honeywells, the Siemens, the Schneiders, ABBs of the world that are traditional OT or operations technology vendors where they've been rolling up or purchasing a lot of the mining IT vendors. And so this IT-OT convergence is obviously a relevant concept in the mining industry at the moment, and it's manifesting itself in some consolidation of the myriad of vendors that sit across both of those sides of the technical business in mining, the IT and the OT. What's interesting is that, as you can see with the Southwests and the Union Pacifics and the Deltas and the FedExes of the world, a lot of these organisations outside of mining have been doing IT-OT convergence for a long time now. So it's not particularly new. It's new for the mining industry, and there's probably good reason for that. But a lot of industries have already been there. And I think my main task at TIBCO in Western Australia at the moment, and probably through Southeast Asia as we get more entrenched in the industry here, is to bring some of this knowledge and capability from these other heavy industries into the mining industry, because I think it's the right time now, and I think the mining industry recognises that. So how do we apply TIBCO technology to mining systems? Well, 17 years ago when I first came to Perth, I think the first customer I dealt with was Western Mining. Western Mining back then had a raft of old VAX VMS systems. For the IT people in the room, you probably know what a VAX VMS system is. If you're as old as I am, some younger IT guys would have no idea what I'm talking about. And if you look at the applications that the mining industry had back in 1995, a lot of these circles up here didn't exist, or if they did exist, they were fairly manual processes. So laboratory systems 15, 17 years ago were quite manual. Access control systems were very manual, and by access control I mean access to systems and linking that to physical access of the site and the assets on the site. Ore body modelling, I mean, applications like Vulcan were certainly there, a lot simpler in their graphical capability than they are now, but they were there. Serpac was emerging. Demand chain optimisation, so pit to port optimisation of moving the ore, the optimisation of that is really a very recent phenomena in the mining industry and IT industry, so that probably didn't exist. Supply chain optimisation didn't exist. So Western Mining in 1995 were just thinking about implementing SAP. So the idea of having a supply chain system, let alone optimising it, was probably quite unique and very new. Fleet management, certainly there wasn't the fleet management systems that exist now. Mining optimisation probably didn't exist at all. There's certainly HR systems and finance systems. But in the last 15 years, there's been an explosion of point solutions in all of these circles. So now you can find a half dozen applications that are dominant and well deployed across the mining industry in the world. in each of those circles. And of course, with that has come an integration problem. So if we talk about mining 1.0 being the adoption of software solutions in each of these categories, then the major problem that we're seeing today in mining 1.0 is this integration problem. So as we've introduced networks and as we've got a bit smarter in the way we use these applications, we've wanted to connect them together. So we've wanted to connect our access control system to our HR system. So if somebody resigns from the organisation, we want the system to make sure they can't get back into the office or back on site or back into a vehicle. We want to integrate our supply chain system with our production systems. So we want to have some visibility from the SCADA systems, from the port loaders, from the car dumpers, to understand and feed that back into the supply chain so that we understand what's physically going on the site. We integrate fleet management with manufacturing execution systems, so our MES systems. We want to integrate lab systems with the ore body, production systems with the ore body, mining optimisation with the ore body, access control with fleet management, demand chain with production systems, manufacturing execution with production systems, demand chain with the mining optimisation systems. That's where we're at today. At the moment, we have an integration problem in most IT shops, in most mining organisations. A lot of it's held together with string and tape, or the equivalent of string and tape in the software terminology. And the problem with this integration overload is that it has a significant impact on the technology budget. So most IT shops in mining are spending 75% of their budget on maintaining the existing infrastructure, and it leaves them with only 25% of their budget to innovate. Now, that's okay if it's a fairly static industry, but with this IT-OT convergence going on, the demands on the IT organisation to be able to produce more and more innovation is significant. And so sitting back and having only 25% of your budget to provide support to the guys that really want to automate the systems and get on with more advanced technologies is detrimental to the business. And so if that was the situation from 1995 to around 2000 and where are we now, 2012, so to maybe 2008, then from 2008 to the current day, I've seen this diagram appear. And I stole this, so full credit to the person from the consulting group that drew it, if you've seen it before. You probably can't read it. There's probably a good reason for that. If you get up close to it, you can't read it. And then trying to understand it is another challenge altogether. But this is the Bible according to the IT consultants to the mining industry in Perth today. And there are a lot of IT organisations trying to achieve this as nirvana, and you can see some insidious little things in here like that integration platform and reporting database in the middle. Big grey box there. I know you can't read it. I'm not going to point to it, but it's there. You see down the bottom the integration between the mining and control systems with the IT systems. So down the bottom here is our IT-OT convergence. I don't know that it's actually possible to achieve that in the real world, and I don't know that anybody ever has. And so my suggestion is that we don't try and do that. The suggestion that I have is we go to what we call event-enabled mining, and that's mining 3.0, and that's where TIBCO comes in. So in the TIBCO world, we simplify this process a lot. We introduce that colourful ring in the middle, which we call the TIBCO integration platform. So the TIBCO real-time integration platform, if you can read that. And then in the middle of that, we introduce what we call our event server. And the event server is able to listen to the information flowing across the integration platform from all of those applications and in real time understand what that information is in context, and then enable the systems or the operators to do something sensible with it. And let me just catch up here with my notes. So the idea of this architecture, I know diagrammatically it doesn't probably float anyone's boat, but the fundamentals here are that we simplify the integration model and make it consistent. And the benefit there is that adding a new application to the ecosystem within the mining IT operation becomes a simple process. Whereas at the moment, if you refer back to our spaghetti diagram, adding a new application and then introducing multiple points of integration is one of the great time wasters in the IT organisations of mining companies at the moment. So simplifying the integration processing and providing a consistent information bus for the data to flow amongst the applications is a significant step change. And it really is the foundation of what we do for all the companies that we event enable. The advantage of having the information bus is that you've then got visibility of the data flows. So you can now see the information that's flowing amongst the applications. And in TIBCO's case, one of the core technical tools, and I promised I wasn't going to get into technology, but one of the core technical tools under all of our products is a thing called Active Spaces. It's a real-time tuple store. It's a real-time data engine that allows us to store all of the information that we want to deal with in memory. And so we have some interesting cases where we have 3-4 terabytes of data in memory and active in real time. In the TIBCO world, we talk about data warehousing as data at rest. We talk about the data that we keep in memory as data in motion. And so TIBCO systems typically deal with a real-time in-memory data store. And we can scale that data store beyond most requirements that we see in any industry today. The intelligence in the middle, so the orange dots in the middle represent events. And one of the challenges I have with typical event processing solutions is that if I take information out of all of these applications, I want to match my ore body information with my lab results, I want to be able to reading measurements coming out of the plant, and I want to be able to analyse that in context and make some sense of that in real time so I can anticipate problems. One of the challenges is that a lot of the information isn't binary. A lot of the information isn't on or off. If something's broken and it's off, well, we don't really need a system to tell us that. We can see that. Sometimes we can work out whether it's going to break before it breaks. But a lot of the measurements out of these systems are variable data sets that the only way a system can understand whether there's a problem is to apply a statistical model to it. And so one of the core capabilities of the TIBCO event management system is to be able to apply a raft of complex algorithms and statistical functions to the data to be able to truly detect problems before they occur, and also to do that in context. And I'll talk about a particular solution that we're looking to apply in Perth in the next few months that will help you understand that idea. So if you look at the top right-hand corner here, the TIBCO event server is about understanding the information flows. It's about anticipating events, anticipating issues before they occur, and then acting. And acting either by presenting a human operator with information so they can act, or by the system acting on its own automatically, and doing that in real time. So that brings us to practical applications in mining. And I know some people here were in Vegas a couple of weeks ago for the Mining Expo. Who was it? Anybody in the room? There's one. Anybody else? 2, 3? Yeah. So you'd recognise the truck in the background, right? Mining Expo, I believe, I've never been to it before, but this year I went, and it's every 4 years, I understand, they have this event. And the thing that surprised me is inside in the hall, they had all of the heavy equipment, so the Komatsu vehicles, the CAT vehicles, the Liebherr vehicles, the excavators, the haul packs. In amongst all these vehicles was a GE locomotive, and I found myself standing next to a train thinking that's just a train. And it looked quite small in amongst all this equipment. It was quite phenomenal. But when we talk about real-time processing in mining, the first thing that comes to my mind is this automation. There seems to be a raft of mines in planning at the moment in Western Australia where autonomous vehicles across the entire pit are core to the design of the mine. Don't know about you, but the idea of 70 of those Komatsu vehicles driving around a pit without any drivers absolutely freaks me out. But they tell me that it's going to happen, and it's going to happen fairly soon. The problem with having autonomous vehicles from a remote operations perspective is that they generate a lot of telemetry information. And I suspect that the owners of the mines don't want to replace 70 drivers with 70 operators sitting in a control room somewhere in Perth watching the statistics and the information, the events that are coming out of these machines. So for TIBCO to be able to take the data feeds from these autonomous vehicles and analyse that information in real time, measure the impact of events that they've anticipated and then react to those events should mean that we can reduce the number of operators required to monitor these autonomous pits from what it would otherwise be if you had a room full of guys just looking at the charts and the graphs and hoping that nothing goes wrong. If we talk about production forecasting, the thing that fascinates me in most IT operations for mining organisations is that there is nowhere to keep the forecast. Most times there is a planning system that plans the production, then there are a set of production targets, and in most cases there's an application that can store the actuals, but I've yet to see an effective system that lets you dynamically manage the forecast. And so there's a lot of IT work going on in a lot of organisations now to try and get the accuracy of the forecast to a point where at the end of the month or the shift or the week, the production number matches the forecast. Reliability-centred maintenance. There are two areas in RCM that I find beg for a solution. The first is being able to make intelligent decisions about the maintenance of assets, big assets, based on their current configuration. So if you look at, go back to Komatsu as an example, Komatsu will deliver a vehicle to a mining organisation and the supply chain guys will put into the maintenance system the vehicle as it is when it was delivered. But 6 months later, a lot of those parts will get swapped out with other parts. Now, who actually knows what the true configuration of the vehicle is? So how do you optimise the maintenance? How do you make sure when it gets in for maintenance that you've ordered the parts that are actually in the vehicle today, not the parts that were in the manifest when it was delivered? So from an automation perspective, it's difficult for a system, a TIBCO system, to truly provide a RCM automated solution if we don't know the as configured today version of the asset. And for vehicles, it's a problem, especially when you have 700 or 800 of those vehicles in your fleet. For oil and gas, it's a phenomenal problem, because if you can imagine a plant like Pluto, over its extended lifetime, the configuration of that plant changes dramatically from the engineering drawings that were originally developed. And so it gets back to that context-based maintenance model that you need to truly provide a good RCM system. And then geology analysis. Most, and Tropicana, I know the guys at Anglo Gold, are any Anglo Gold people here today? Anglo Gold at Tropicana are doing some great work on the connection between the geologic models, the pit design, what they think is in the ground, and the plant, and the chemistry in the plant. And so being able to connect those two systems together requires an event management tool and an information management tool that has true knowledge of the three-dimensional block model and the pit model and the strata in the pit, as well as what's going on in the plant, the chemistry of the plant. But if you can achieve that, then being able to squeeze a bit more efficiency out of a gold operation is obviously can produce a much better profit result for the organisation. So it's a valuable place to look for automation and opportunities for efficiencies. So at that point, let me just go back here. So I was going to tell you about our asset maintenance solution. If we go back to the Southwest Airline example, one of the things we do for Southwest and for Delta is we we help them plan and schedule maintenance of the jet engines from the planes. And if you look at an oil and gas operation, they have similar sorts of technology for compressing the gas and getting gas out of the ground. And in mining, it applies to vehicles as well. For jet engines, we built a statistical model that understands the interaction between the parts in the engine. And so when you talk about monitoring SCADA information coming out of a piece of plant, you can tell when things are on and off, you can tell when things are broken, but in isolation it's difficult to be smart about how you maintain the asset if you don't understand the severity of a problem and the impact that the problem has on other parts of the asset. And so for GE engines, I believe they were, we built a statistical model that lets them rank the severity and the impact of problems that they're detecting from the SCADA data feeds, then determine when the plane lands if they do a little bit of maintenance on the things that have a high impact but are easy to get to, and then they schedule the maintenance of the things that have a low impact but are difficult to get to for when the engine's taken offline and out of service. But the only way you can really do that effectively is if your statistical model about the asset understands the relationship between the parts that you're thinking about replacing, the parts that you're monitoring, and the other parts in the ecosystem of the asset, or the engine in this case. And so in terms of, for reliability-centred maintenance to be truly effective, asset maintenance to be truly effective, then we need to add an intelligence layer to the event engine that lets you determine the severity and the impact of the problems that you're detecting to work out the best way to maintain the assets. So the challenges that remain. Consistent view of distributed operations. I think once you get it right for one pit, then obviously the miners that we deal with have operations across the globe. And the challenge from an IT perspective of getting a consistent view of distributed operations is that all the operations tend to use different tools and different software products for the different facets of their business. And so again, with a very standardised integration model and the ability to read the data in real time from a raft of different sources, we don't need to go to the pain of trying to have a consistent ecosystem of applications. And we've seen that at places like Rio Tinto and BHP and Western Mining over the years where to get a consistent view of distributed operations, the first thing the IT guys think of is having the same piece of software across the world. So we'll put SAP in across the world. 10 years later, we've managed to achieve that. We still don't really have good real-time reporting out of that. If you look at some of the applications, like payroll, payroll across 3 different countries and 3 different currencies can be quite a challenge to have a single application that can do that well. In the TIBCO view of the world, you don't need to have consistent applications across the world to be able to integrate the data and to be able to get a consistent view of what's going on in your business. Timely end of period reports, we talked about the forecast gap, and I think the thing that I see in most mining organisations is a lot of people sitting around waiting for the data warehouse guys to produce reports. And so if we can move away from data warehousing and move into real-time analysis of data sources, then we don't have that wait period between when you need the information, when the IT guys can deliver it for you as a report out of the data warehouse. Accurate post-event analysis. Another challenge that I see quite often is that something bad will happen in operations, but by the time you get around to analysing what it was and what the cause was, determine that causality, the information is just too hard to get to be able to put it together in a meaningful way. And if you come out to our booth, you can see some interesting reports around, or visualisations of real-time information that are both predictive, so predictive analysis of what's going to happen, but also systems tend to allow operators and general users to drill down into the information across multiple systems, mash it up and be more deterministic about what caused a problem or an event that they need to analyse. Real-time feedback of performance to plan. Once you do the first one, which is get a consistent view of distributed operations, and you make that connection between the forecast and the actual, then the next step in that process is to feed it back into the plan. And how quickly you can adjust the plan so that you can modify the operation to get back on track as far as your production requirement is concerned, the better your operation is going to perform. So again, TIBCO opportunity, integrate the planning system with the actual and the forecast, and then close that loop, feed it back into the plan. Preempting unplanned events, that is really bread and butter for us, and I think I've covered that enough. But I think the core mantra that I have in this space is managing what's important rather than monitoring everything. And it gets back to that autonomous vehicle example. There's not a lot of efficiency in replacing 70 drivers with 70 guys in an operations room, each one watching a truck. You really want the system to be able to identify the events that are important and let the staff deal with the events that need to be dealt with in a timely manner, not employ a lot more people to just look at more graphs and more charts and more data feeds and wait for something to happen. Barriers to progress. More applications create more integration, and so what we're seeing at the moment is IT organisations being choked by demand from operations to add more and more technology to the business, and then the integration problem becomes a bottleneck. Multiple data sources overlap but don't synchronise. I was looking earlier this year at the integration between a mine planning system or production monitoring system and a metal accounting system. And when you look at those two applications, it doesn't matter which vendor and which application you pick, the way they describe the data, the physical, the way the databases describe the physical stockpiles and ore flows in the mine are fundamentally different. So integrating a metal accounting application and a mine planning application is just it's a nightmare in anyone's business. And so being able to move away from that point-to-point integration model into a consistent information flow model, and then being able to look at both data sources as they stand in real time is much more effective than trying to create data warehouses and aggregated data sources across those applications, because the information, the configuration of those systems is typically dynamic. And so you just never catch up. By the time you get the integration right, somebody's reconfigured the system, you have to go back and integrate it again. Too much data to manage effectively. Yes, and as we add more autonomy and we integrate IT and OT, the data feeds and the data sources and the information flows are getting greater and greater and greater exponentially. Information system complexity drags on the business, and I think this is, it used to be that the IT guys were always ahead of the organisation innovating, but now I see the operations guys pushing the IT guys to get on with it and do more and do it quicker. And a lot of that is coming because the technology that's being introduced to the organisation is coming from the outside. So the Caterpillars, the Komatsus of the world are introducing technology into these businesses that they otherwise didn't choose to have. So the IT guys are running to catch up instead of being innovative and being ahead of the curve. And so the objective for me, certainly in my work with the mining industry in Western Australia for the next 12 months, is to try and reverse the trend. Try and go from 75% maintenance and 25% innovation to 75% innovation, 25% maintenance. So the TIBCO approach, simplified and broaden the systems integration, we've talked about that. Present information in context interactively. Derive events from data at scale and in real time. Automate responses via system or human processes, and I think we've covered all that. And what that would mean is that we're delivering Mining 3. And to recap, and this is the last slide, for TIBCO, we provide event enablement for organisations. We automate the machine and human processes. We provide interactive analytics across live systems. We provide you with the back-end integration and infrastructure to deal with big data. And big data is a term that we've heard in banking and finance and insurance and airlines for years, and I'm starting to hear it from the mining industry at the moment. And then we have social style professional collaboration to disseminate and distribute information to help people collaborate with the events and the things that they're seeing happening in their IT systems across the organisation. And that is the TIBCO story. Thank you very much.